Imagine waking up one morning to find out that diesel trucks, the backbone of American logistics, just stopped buying fuel. No gas stations, no refueling stops, no diesel bills. Instead, they just kept moving. That's exactly what some insiders are quietly claiming is happening right now. U.S. transportation companies have reportedly begun testing a conversion technology linked to Maxwell Chikumbutso, the inventor who claims to make engines run without fuel, batteries, or charging. And if those claims are true, then the diesel era as we know it might be in its final chapter. But how did America get involved in a technology that most scientists still call impossible on paper? And how did a prototype from Southern Africa end up inside U.S. trucking fleets? To answer that, we need to go back to the initial pitch. Maxwell's engineers approach logistics companies with a promise. Keep your existing trucks, keep your existing engines, but remove the dependency on diesel. The conversion doesn't replace the drivetrain. It replaces the fuel system with what they call an MSCDL drive unit, designed to generate its own operational power using internal RF energy cycles. If that sounds confusing or unbelievable, that's how early reports described it too. Even engineers inside the companies were skeptical. Some thought it was a prank. Others thought it was another internet hoax. But after fuel prices skyrocketed in 2024, logistics companies became desperate for alternatives. It wasn't about belief anymore, it was about survival. So, the first conversions happened. According to technicians who were present, the retrofit took less than a day. Diesel tanks remained in place for safety, but the engines were no longer connected to them. After calibration, the trucks rolled out of the warehouse, drivers put them on the highway, and the real testing began. At first, everyone expected the trucks to stall after a few miles. Instead, they didn't. They accelerated, cruised, and returned back to the facilities several hours later, with zero fuel consumption recorded. The initial test would have been dismissed as staged if not for the second, third, and fourth trucks reportedly showing the same behavior. By the end of the first week, company observers were calling it the most disruptive thing since the electric forklift. Of course, not everyone was celebrating. Diesel suppliers tried to purchase documentation. Regulators demanded explanations. Fuel lobbyists insisted it was dangerous. And engineers demanded proof from third-party laboratories. But that didn't stop the conversions. Within 3 months, over 100 diesel trucks across several U.S. states were reportedly retrofitted. Some companies used them for short-distance urban deliveries. Others pushed them through long-haul interstate routes. The most shocking detail? None of the test trucks have visited a gas station since their conversion. And that's where things get even more interesting. Fleet managers started running cost calculations. A standard Class 8 diesel truck in the U.S. averages around $70,000 to $120,000 per year in fuel costs alone. Multiply that by 100 trucks, and you're looking at roughly $7 to $12 million annually. Eliminating that expense isn't just disruptive, it's catastrophic for the fuel industry. That's when the first quiet restrictions began. Fuel industry representatives started investigating the retrofit suppliers. Insurance companies began asking questions about non-standard propulsion systems. Federal agencies requested technical diagrams that, so far, have not been released publicly. And yet, companies close to the project are refusing to back down. One fleet manager reportedly said, "If the physics textbooks say it can't work, the textbooks need updating, not the trucks." Meanwhile, public information about the technology remains incredibly limited. Even naming the system sparks debate. Supporters call it fuel-free. Critics call it pseudoscience. Engineers call it industry-breaking, even if they can't fully explain it. And this is where we'll leave the story for now, right at the moment when an African-born technology is forcing the U.S. transportation sector to reconsider everything from logistics to energy independence, while the diesel era quietly approaches its expiration date. From the moment the upgraded convoy hit the interstate, something fell off. Not in a bad way, just different. Drivers reported smooth acceleration, quieter cabins, and strangely consistent torque even on steep gradients. Without diesel vibration and combustion noise, the 18-wheelers glided more like electric locomotives than trucks. The Department of Energy observer in the chase vehicle kept taking notes, glancing up every few seconds as if waiting for the first breakdown. Except none happened. Mile after mile, city to desert, desert to mountains, the trucks just kept going. No refueling, no idling, no emissions plume. For a sector where uptime equals money, the numbers were alarming in the best possible way. By the second week, trucking analysts started tracking the test fleet. Some called it a PR stunt. Others warned that if it scaled, it could obliterate diesel demand in less than a decade. One analyst put it bluntly during a CNBC segment: if even 10% of America's heavy-duty trucks convert to self-powered systems, the oil market enters a permanent demand crisis. Of course, the petroleum lobby didn't sit quietly. A leaked email chain from a major fuel lobbying organization questioned the safety, the energy legitimacy, and the national security implications of fuel-independent transport systems. But panic behind closed doors couldn't stop what was unfolding on the roads. Because by month 3, something even more disruptive happened. 2 independent logistics companies, one in Texas and one in Ohio, approached the Maxwell team requesting conversions for their fleets. They didn't care about hype, politics, or debates. They ran the numbers. Diesel at scale accounts for up to 30% of operational cost. If that number drops close to zero, margins change, pricing wars begin, and the entire logistics map gets rewritten. Inside the Maxwell workshop in Arizona, the conversion line grew faster than anyone expected. Mechanics worked alongside electrical engineers, wiring control units, balancing supercapacitors, and retrofitting drivetrain interfaces. Veteran truckers stopped by out of curiosity, staring at the systems with crossed arms. No roaring engines, no exhaust fumes, just silent power units that looked more like aerospace equipment than anything you'd see in a Peterbilt. What happens when it breaks down? One asked. It doesn't really break down, the tech shrugged. There's no combustion, no oil, no filters. The wear points are mostly mechanical. The trucker laughed under his breath, not fully believing it, but he stayed anyway, watching. When the first independent fleet conversion completed, the owners signed NDAs and rolled out quietly. But nothing stays quiet forever. 2 weeks later, dashcam footage leaked. A convoy moving through the Rockies with 0 refueling stops. The video hit 12 million views in 3 days. Comment sections exploded. Young engineers called it the Tesla moment for trucks. Older drivers dismissed it as edited. But logistics executives took notice. And then came the moment nobody expected. A representative from the U.S. Army Transportation Command flew in for a private tour. Military supply chains run on diesel more than anything else. Convoys, generators, field logistics. Fuel is the lifeblood, and the military spends billions moving it. If fuel becomes optional, deployment math changes overnight. The visit lasted 4 hours. No photos leaked, no recording surfaced, no statements issued. But after that visit, everything accelerated. A new facility location was scouted. A manufacturing partner from Michigan joined the talks. And the first non-disclosure agreements between Maxwell's team and federal contractors were drafted. Meanwhile, diesel suppliers braced. Some began quietly shifting toward battery investments. Others doubled down on lobbying. But the trend lines didn't care. Truckers uploaded videos praising lower maintenance costs, smoother drives, and no diesel smell in the cab. Mechanics posted breakdown kits showing how few moving parts remained. Startups pitched new charging-less logistics networks built around continuous operation. Industry insiders started whispering a phrase that once sounded ridiculous: post-fuel trucking. And for the first time, it wasn't science fiction. The real shock came when Mexico, Brazil, and South Africa requested technical documentation for their own heavy-duty fleets. Because in those markets, diesel is even more expensive, infrastructure is weaker, and operational savings matter more. Under rising pressure, oil analysts tried to downplay the trend, calling it niche, and proven, and limited in scope. But those narratives collapsed when the conversion data surfaced during a closed-door logistics conference in Chicago. The presentation, intended only for industry, was leaked within hours. It showed uptime charts, maintenance logs, and energy output stability across 100 trucks over 9 months. No diesel expenditure, no fuel logistics, no drop in torque output. One slide in particular sent the industry into panic mode. Total operational savings per truck per year. The figure wasn't 5% or 15%. It was over 40%. 40% saved, simply by removing fuel from the equation. That number hit harder than any YouTube video or rumor ever could, because it immediately translated into deadly real-world consequences for the old system. Fuel distributors, refining supply chains, maintenance shops built around oil changes, gasket replacements, and filter cycles. Even highway gas stations designed around diesel lanes. If fleets go electric, they suffer. If fleets go self-powered, they disappear. By early spring, rumors circulated that a major American carrier, a company operating over 10,000 trucks, was evaluating a pilot conversion program. The rumor alone hammered several oil stocks in a single day. Shareholders demanded clarity. CEOs issued vague statements about monitoring new propulsion technologies and exploring hybrid energy diversification. None of them acknowledged that for the first time in history, the fuel model itself was under threat. Meanwhile, inside the Arizona facility, morale surged. Engineers brought in aerospace-grade monitoring systems, machine vision diagnostics, and adaptive load management firmware. Mechanics joked that they were retiring diesel faster than the government ever could. Trucker culture didn't change overnight, though. At truck stops, converted rigs parked alongside traditional diesel giants, and the contrast was surreal. No rumbling engines idling through the night. No fuel receipts. No fumes. Drivers from both worlds traded stories. Diesel veterans were skeptical but curious. Younger drivers were excited and saw it as an escape from volatile fuel prices. One converted trucker told a reporter off camera, "You don't realize how much of your shift is fuel-related until you remove the fuel. I'm just driving. That's it." But the real breakthrough came during an emergency scenario, one that nobody planned for. A logistics warehouse in Nevada experienced a grid outage during peak operations. Diesel forklifts couldn't refuel, electric forklifts couldn't recharge. The line froze. Every second cost money. Then something unexpected happened. One of Maxwell's converted Class 8 rigs on-site provided auxiliary power through a high-voltage port designed for diagnostics. Within minutes, lights came back on and forklifts resumed movement. Witnesses described it as watching a truck turn into a generator. A clip of it powering the warehouse hit TikTok and spread to engineering circles on LinkedIn. Suddenly, investors realized the system wasn't just eliminating fuel, it was introducing mobile energy infrastructure. Trucks weren't consumers of energy anymore. They were providers. That was the moment national regulators stepped in. The Federal Motor Carrier Safety Administration requested a formal briefing. Wall Street analysts issued emergency revisions to long-term oil forecasts. And 5 senators from energy-heavy states demanded hearings on the economic risks of post-fuel transportation. The irony? While politicians argued in Washington, the world kept moving. A logistics chain in Mexico City completed its first Maxwell-assisted route. A mining company in Chile began feasibility analysis for remote site conversions. And in Johannesburg, a tech magazine ran a cover story titled, "Africa Invented Fuel-Free Freight Before the West Even Noticed." By the end of the year, the question wasn't whether Maxwell's fuel-free conversion system would scale. It was who would control it, who would try to regulate it, and who would attempt to stop it. Behind the scenes, a very different battle was unfolding, one that never made it to news feeds or investor reports. A consortium of legacy energy interests quietly commissioned a private assessment. The document, later leaked by a cybersecurity research group, outlined 2 urgent threats: the decentralization of energy and the destabilization of the global fuel trade. The language was blunt. If fuel-free transportation proliferated, it would erode revenue streams faster than renewables ever had. Oil didn't lose to solar panels or wind turbines. It lost to the removal of demand. The report warned that once logistics fleets convert, other sectors inevitably follow: agriculture, construction, emergency services, and eventually personal vehicles. In other words, self-powered freight wasn't a novelty, it was a keystone. Break it, and the old system survives. Let it grow, and oil becomes a historical commodity. Meanwhile, Maxwell's team remained focused on practical realities. They weren't thinking about geopolitics or stock prices. They were trying to deliver finished trucks on schedule. But pressure mounted from the shadows. Suppliers suddenly delayed shipments, certifications got tangled in red tape, and inspectors appeared unannounced with new requirements each week. Nothing illegal, just friction, death by 1,000 paper cuts. But the global internet had already taken notice. Independent engineers began replicating parts of the system using publicly available schematics Maxwell had shared years earlier. Forums erupted with debates about dielectric resonance, magnetic coupling, and closed-loop energy recovery. Even though full replication was out of reach, the community was evolving fast. Then came the second accidental demonstration. A converted truck hauling automated robotics equipment encountered a mechanical failure near a rural Midwestern community. Nothing dramatic, a broken hub, no injuries, but it stranded the driver miles from any service center. A local volunteer fire department arrived first. They needed power for rescue tools, radios, and floodlights. The truck provided it, silently, without fuel, for 5 straight hours. A firefighter posted a photo. Rescue crews working under bright floodlights with a quiet semi acting as the energy source. The caption read, "Truck broke down. Powered the entire scene." The post hit 3 million views in 24 hours. Fire departments nationwide started asking questions. FEMA noticed. So did military logistics units. Suddenly, fuel-free wasn't just about economics, it was about resilience. By late summer, several U.S. defense procurement analysts visited the Arizona facility in plain clothes. They didn't talk publicity. They asked about energy density, cold weather performance, electromagnetic shielding, and tactical use cases. Engineers answered carefully. They weren't interested in weaponization. But they also weren't naive. Once you create autonomous mobile energy nodes, national security will pay attention. Yet for all the high-level intrigue, something simpler was happening at the human level. Drivers who had been in the industry for decades started talking about retiring later because the job was easier. Mechanics began transitioning from grease and filters to firmware and thermal diagnostics. Communities living near major freight corridors noticed cleaner air and quieter nights. Small things that don't make headlines, but matter to people living inside the system. And while the old guard scrambled for countermeasures, Maxwell himself remained mostly silent. He didn't give interviews. He didn't release statements. The only public appearance he made all year was at a small engineering symposium in Nairobi, where he spoke directly to young students. His message was simple. Energy should serve humanity, not control it. The clip barely registered in the West. But in communities across Africa, where rolling blackouts, fuel shortages, and infrastructure gaps are real daily barriers, it became a rallying phrase. Because for them, the idea of fuel-free logistics wasn't disruptive capitalism. It was liberation. By winter, the Arizona fleet hit a new milestone, 1 million cumulative miles without diesel. When the final data logged and verified, engineers paused, not because it was the end, but because they understood what it meant. 1 million miles of freight, commerce, and movement, without burning a drop of fuel. No war for oil. No tanker spills. No refinery emissions. Just motion. The philosophical question echoed far beyond engineering circles. It reached lawmakers, investment firms, climate analysts, military strategists, even ethicists. Everyone had a different answer. Everyone had something to lose or something to gain. But for the Arizona fleet, the transition from experimental to operational was already underway. Insurance companies, normally slow adopters, added a new risk category called fuel-free power systems. At first it was a bureaucratic hassle, but soon the data spoke for itself. With fewer mechanical failures, cleaner engines, and reduced fire hazards, premiums began dropping for converted trucks. Analysts drafted a quiet memo. If scaled, fuel-free logistics could reduce national insurance losses by billions over a decade. Small business owners noticed. A regional grocery distributor in New Mexico was the first non-government contract to request a fleet trial. Not because they wanted to make headlines, but because their margins were collapsing under fuel costs, and this was the first lifeline they'd seen in years. Meanwhile, organizations monitoring the energy transition started connecting dots. Grid operators realized that mobile, self-powered trucks could double as emergency microgrids. EV skeptics realized that range anxiety disappears if the range is effectively infinite. Humanitarian groups realized that aid convoys in disaster zones could operate without fuel supply chains. The world realized something else too. The fuel-free truck wasn't competing with electric vehicles. It was leapfrogging them. That's when Europe finally got involved. A delegation from Germany's Federal Ministry of Digital and Transport sent observers, under strict confidentiality, to document performance. Their report, leaked a month later, contained a line that became legendary among engineers. If verified and scalable, this represents the first credible path to post-fuel mobility without grid dependency. Suddenly, the debate was no longer, does it work? The debate shifted to who gets it first. And that's when the pushback reached a new phase. A U.S. senator, backed by legacy energy donors, introduced a bill proposing new regulatory classifications for non-fuel propulsion systems. It sounded harmless on TV, but hidden in the legal language were requirements that could delay certification for 5 to 7 years. Within days, analysts called it what it was, a stalling tactic. But something unexpected happened. A coalition of logistics companies, rural mayors, and emergency response organizations pushed back, publicly. Their argument was simple: America's supply chain is fragile enough already. If there's a technology that strengthens it, don't bury it in paperwork. Public sentiment started shifting too. Not because people cared about physics or patents, but because they understood fuel prices, pollution, and economic bottlenecks. Then came the moment that changed the conversation globally. A converted truck was deployed to assist during a wildfire event in California.